Droughts, loss of fertile land, and growing water scarcity accelerate in a vicious cycle, and sandy soils are particularly exposed, threatening agriculture, which now consumes more than 70% of all available fresh water on Earth. When fertile soil turns to sand, even more water is needed to maintain life and grow food. Less than 15% of water applied, through rainfall or irrigation, is retained in the topsoil long enough for plants to make use of it. Most of the water is quickly lost to deep drainage, causing fertilizer washout, increasing costs, and lost productivity. Let's look deeper into why sandy soils are so poor in retaining water. Sandy soils consist primarily of sand grains, which are large particles. Think of a jar filled with marbles. Large marbles will have big void spaces of air between them compared to small marbles, and water will flow through quickly. Sand grains also lack surface charge, which means that charged particles like water have nothing to stick to, and nothing binds the sand particles together to form a good soil structure. Liquid natural clay, in short LNC, is a nature-based solution to upgrade sandy soils with a larger storage bank. LNC is a liquid nearly as thin as water that percolates into the ground by the force of gravity. The liquid consists of natural minerals with tiny charged clay particles that coats each grain of sand with an electrical charge that holds onto water like a magnetic force. LNC also introduces natural minerals designed to increase the total surface area of the soil. Think of surface area as a small kitchen table and imagine pouring a bucket of water onto it. Most of the water will end on the floor. Increasing the surface area is like upgrading to a larger table. More water will remain on the surface. Now let's combine surface area with electrical charge. Without surface charge, nothing holds the water onto the table, and if it's lifted to an elevated angle, all the water will run off the surface and be lost. LNC adds specific surface charges that enables particles of opposing charge like water to stick to the surface. The final stage of the LNC process is formation of what's called clay bridges, which binds the sand grains together into soil aggregates, forming a structure similar to dark, rich soil that retains water and nutrients like a sponge. Let's compare LNC-treated sand to the before-treatment sand. Water is essential for plant growth, but sandy soil struggles to retain it, leaving the soil thirsty and unproductive. Fertilizer is equally important, but without water retention, it simply washes away. With LNC, sandy soil becomes enriched with charged particles, helping it to retain water and nutrients for healthier and more fruitful crops, which will save up to 50% on water and energy usage while improving fertilizer efficiency, leading to higher yields, better crop quality, and increased profit. For thousands of years, we've known that clay and natural minerals are essential for soil quality and drought resilience. Adding clay to sand is difficult, risky, and resource-intensive. It can fill up the air spaces in soil and requires enormous amounts of clay, up to 100 kilograms per square meter. LNC solves these challenges by exfoliating clay into tiny platelets mixed into a liquid state, reducing the amount needed per square meter from 100 kilograms to less than 1 kilogram. Using LNC is an efficient and effective way to add essential minerals to soil, resulting in healthier plants and greater